Good morning, students. Today we will have a discussion in Unit 2, and the problems whatever we're going to discuss today is also from the previous year question papers. All the best. Thank you. Let us consider this problem. So in this problem, you can able to see that the question is related to springs. So they are given 3 springs. They're asking to calculate what is the global stiffness matrix and also displacements at node 2 and node 3. And reaction forces at node 1 and node 4. They have mentioned you what is the stiffness of the spring, that is K1 and K3 is equal to 10 Newton per meter and K2 is 200 Newton per meter. They also mentioned there is a force which is acting at nodal point 3 which is 500 Newton acting towards right hand side. So usually in the Mari problem we have solved by using bar element. So bar order element, if I consider a bar, so what we'll say, we identify stiffness matrix K, which is equal to, the formula for stiffness matrix will be AE by L 1 minus 1 minus 1 1. Actually we can check that. So this AE by L is nothing but your stiffness of this bar. So A என்றது வந்து யூனிட் செக் பண்ணி பார்க்கலாம். இப்போ ஏன்றது வந்து யூனிட் வந்து பார்த்தீங்கன்னா மீட்டர் ஸ்கொயர், ஈன்றது நியூட்டன் பர் மீட்டர் ஸ்கொயர், அதேமாதிரி எல்ன்றது வந்து ஒரு மீட்டர், ஸோ டிவைடட் பை மீட்டர். ஓகேங்களா? ஸோ இப்போ என்ன ஆகுது, இது கேன்சல் ஆகுது. ஸோ உங்களோட யூனிட்டே வந்து பார்த்தீங்கன்னா நியூட்டன் பர் மீட்டரில் இருக்குது. ஸோ விச் மீன்ஸ் திஸ் இட் செல்ஃப் இஸ் தி ஸ்டிஃப்னஸ் ஆஃப் அ ஸ்ப்ரிங். ஸோ வி ஆர் கன்வெர்ட்டிங் அ பார் டு அ ஸ்ப்ரிங். So, but here they are given directly what is the spring. In that case, our matrix will be like K will be equal to, so nothing but K minus K minus K K. Right? So where K is the stiffness of a particular spring. So if it is spring 1, so it will be K1, 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 K1. So this is the matrix for this particular spring. Okay. This is the formula we are going to use for this entire sets. So now let us consider what is the element diagram for this particular problem. So if I consider what is the elemental diagram, you can able to see that we have 1, 2, 3 elements. So we have 3 elements. So which is element 1, element 2 and element 3. So this is element 1, this element 2, this element 3. And this elements is having nodal point 1, 2, 3 and 4. So this is the entire sets. So your element matrix. So we also know what is our K1 so and K3. So this K1 and K3 they mentioned as 100. It is 100. Similarly, so your K2 is mentioned as 200. They also mentioned that your U1 and U4 are zeros and you have a P which is equal to 500 Newton. So here you have a P which is 500 Newton. So if you want to draw what is the element diagram, you also mentioned, so you have an input of F1 and the output will be U1. Similarly here you have an input of F2 force and the output will be your displacement U2. Similarly this will be F3 U3 and this will be F4 U4. So now let us solve, let us identify what is the stiffness matrix for each of this element. And you can able to see that there is no need for identifying what is the length. So in the problem itself they have not mentioned anything about length, because AE by L is the stiffness matrix. They are directly given what is the stiffness. In that case you no need to worry about what is the length of this. Directly we can substitute it accordingly. Now let us consider what is the stiffness matrix for element 1. So element 1 we call it as K. So it is connecting nodal point 1 and 2 and this will be equal to, so common K1 I will take it out, into 1 minus 1 minus 1 1, or you can also write it inside. So better we will write it inside. So K1 is 100. In that case, so I will write it inside. So I will get 100 minus 100 minus 100 and 100. So this is my element 1. And if you look after what is the address of this particular element, it is connecting nodal point 1 and 2. In that case, so you can able to see that this will be 1, this will be 2, similarly this will be 1 and this will be 2. This is for element 1. Next we will go for element 2. If we go for element 2, again your K is connecting nodal point 2 and 3. So this is connecting nodal point 2 and 3. So which is equal to K2 minus K2 minus K2 and K2. So you know that K2 value is 200. In that case, I can write it as 200 minus 200 minus 200 and 200. The address of this particular matrix is connecting 2 and 3, nodal point 2 and 3. In that case, this will be 2, this will be 3, similarly this will be 2 and this will be 3. For element 3, again your K is connecting nodal point 3 and 4, and the formula will be K3 minus K3 minus K3 and K3. So which will be equal to, since K3 and K1 both are 100, so this will be 100 minus 100 minus 100 and 100. And this is connecting nodal point 3 and 4. In that case, so we will consider this as 3, 4 and this also 3 and 4. The next step is you have to identify what is the global stiffness matrix. Let us go for global stiffness matrix. To identify global stiffness matrix, first you have to identify what is the size of my matrix. The size depends on number of nodes multiplied with degrees of freedom per node. You have U1 is the degrees of freedom. You have 1 degree of freedom for each node. And number of nodal point is 1, 2, 3 and 4. So it is 4 into 1. So we will call this as 4. Number of node is 4 and degrees of freedom is 1 per node. So the size will be 4, which is 4 cross 4 matrix. So your global stiffness matrix K will be in terms of a matrix. The size of this matrix will be a 4 cross 4 matrix. So which is having nodal point 1, nodal point 2, nodal point 3 and nodal point 4. Similarly, nodal point 1, 2, 3 and 4. Okay, so for better convenience, I am going to draw some lines so that it is easy for you to understand where I am assembling it. So now you can able to see that you have a grid-like system where I have to assemble it accordingly. So let me consider one by one. So what is the values related to that? Let me consider element 1. Element 1 address is 1, 2 and 1, 2. So 100 minus 100 minus 100, 100. So fill it at 1, 2 and 1, 2. So this will be 100. This is minus 100. This is minus 100 and this is 100. Next we'll go for 2, 3. 2, 3 is 200 minus 200 minus 200, 200 and it is connecting 2, 3, 2, 3. So where is my 2? 2, 2 is here. So which is plus 200 minus 200 minus 200 and 200. Next is 3, 4. 3, 4 is 100 minus 100 minus 100 minus 100 and this is 3, 4 connecting 3, 4. So in that case this is be plus 100 minus 100 minus 100 is and 100. So remaining terms will be zeros. So which means this will be 0, this will be 0, this will be 0. Similarly these are all zeros. So let us add it and we will write down what is my global stiffness matrix. So my global stiffness matrix will be K. So this is my stiffness matrix, overall global stiffness matrix. So this is one of the answer which is asked, global stiffness matrix, which we have identified. The next step is I have to identify what is my displacement. Okay, so to identify the displacement, you know that force is equal to your stiffness matrix K into your displacement U. So input force is equal to your stiffness matrix into your displacement. So let us identify what is the forces. If I want to identify the force, so force will be in terms of F1, F2, F3 and F4 in column matrix. Since we have force only in nodal point 3, so we have only F3. Okay, so in that case, your force matrix F, I can write it as F1, F2, F3 and F4, in which only F3 is available. So remaining things are 0. So this will be 0, 0. So F3 is identify 500 and 0. So this is my force matrix. So this is also addressed in terms of 1, 2, 3 and 4. So now let me substitute it. So what is my F and what is my K and what is my U? Global stiffness matrix, and this is equal to your displacements. What is my displacement? You have displacement U1, U2, U3 and U4. So these are my displacements. So when I address this, I will write it as 1, 2, 3, 4. Similarly here also it is 1, 2, 3, 4 and this is also 1, 2, 3, 4. So this is the arrangement of F is equal to K into U. Now if you look after what is my values, so you know that you don't have displacement in nodal point 1 and nodal point 4. Suppose the random is 0. So when you say it is 0, I can strike that row and column. So in that case, first row illa and first column also you can cancel it. Similarly, last row, so U4, last row illa, so we can cancel that, and last column we can cancel it. So what are the remaining terms? That will be considered for calculation. So what are my remaining terms? My remaining terms will be 0, 500 is equal to, we have 300 minus 200 minus 200 and 300. So this into values are U2 and U3. So now we will write this in an equation format. First equation, 0 is equal to 300 into U2. So I will write as 300 U2 minus 200 U3, minus 200 U3. This is equation number 1. Second equation, so 500 is equal to minus 200 U2, so minus 200 U2 plus 300 U3, 300 U3. This is equation number 2. So now I got two equations and we have two unknowns. So only thing is I have to solve these two equations and unknowns. Let me show you how to solve this in calculator. So let's open this calculator. So go to mode, so press mode and go to EQ1, so 5. In this, so we are going to consider two unknowns, so which is first equation, so A and B n. So let me go for 1. It is asking the first value. So this is in terms of A, B, C. So A is your value related to U2, B is value related to U3 and C is your equal to, after equal to whatever the terms, that is your C. So this will be 300, press arrow, sorry, I'll press equal to, next minus 200, press equal to, and it is 0, press equal to, next this will be minus 200, equal to, then 300, equal to, and 500. Once you enter, press equal to, you will get what is the values of x. X is nothing but U2. So U2 is 2 mm, 2 meter, I think it is in meter, and your U3, if I solve this, let me press equal to again, U3 will be 3, it is 3 meter. So this will be the answer for my second part. So U2 and U3 values which is asked. So according to this, your nodal displacement U2 and U3 are identified as 2 and 3 meters. The next thing is they are asking you to identify what is the reaction force. You have a formula set. what is the formula set? Your R is equal to K, your stiffness matrix K into U star minus F, your force. What is this U star? U star means already identified values, what we identified here. So U2 we identified, right? So that value is U star. Okay. So this is your formula to identify what is the reaction force. So our reaction force is in terms of R1, R2, R3 and R4 is equal to your K values. K into U star. You know that U1 is 0, U2 we identified, U2 is 2, U3 is 3, U4 is 0. Okay, minus your value. So your F values is 0, 0, 500, 0. Most of the time, you just to minimize your work, உங்களுக்கு என்ன தெரியும்னா எங்க reaction வரும். So where you will have a reaction will be identified only if there is no displacement. So இப்போ இந்த ப்ராப்ளம்ல பார்த்தீங்கன்னா displacement இல்லாத இடம் என்னன்னு பார்த்தீங்கன்னா 1 and 4. So questionலயே அதான் 1 and 4 தான் கேட்டிருக்காங்க. You concentrate to identify only on these two locations. You no need to calculate everything. So this will minimize your time. Okay, so for that let us identify. So since they are asking reaction force for R1 and R4, so 1 and 4, I am going to concentrate only on this two. So let me go for R1. So what is my R1? Just multiply 100 into 0, which is 0, minus 100 into 2, so minus 200, 0 into 3, 0, 0 into 0, 0, minus this. Okay, so minus F is 0. Okay, so R1 is nothing but minus 200. Similarly, R4, reaction 4. Go for reaction 4. 0 into 0, 0. 0 into 2, that is also 0. So plus 0. Minus 100 into 3, so minus 300. Plus 100 into 0, that is also 0. So which is equal to minus 300. Okay, so my reactions are R1 is minus 200 Newton and R2 is minus 300 Newton. If you want to identify, so if you want to verify whether the answer is right or not, whenever you add all your reactions, that will be equal to your amount of force. So மொத்த force வந்து 500 பாசிட்டிவ்ல இருக்கு. இப்போ ரியாக்ஷன் வந்து minus 500 இருக்கும். So இங்க என்ன இருக்கு 200 and 300. So adding it, you are getting minus 500. So this completes this problem. Thank you.